All right, let's start the review. Going back into measurement conversions from quite a while ago, a few weeks ago, we want to look at each problem and see first if we're using the metric conversions or customary. In this case, number one, if I'm going from 1 million kilometers to centimeters, this is in metric. So if I am moving in metric, then all I need to remember is the little acronym King Henry died by drinking chocolate milk, where the K stands for kilo, hecto, deca. The base unit is your meters, liters, and grams in the middle, and then deci, centi, and milli. And another thing you might want to go ahead and write down are these little helpful tips here. Pause the recording and write this down where mile equals 5,280 feet. 1 inch is 2.54 centimeters. A pound is 454 grams. And then this is the big G for the gallon man, where inside of the G you have 4 quarts equals a gallon, and there are 2 pints in every quart and 2 cups in every pint. So yeah, go ahead and pause, write that down. I will give you a metric conversion like chart at the top of your test. I just neglected to put it on the review. So on the test, don't worry, I got you. So back to number one. If I'm converting in metrics from kilometers to centimeters, all I have to do is move my decimal the number of times over from each prefix. If you look at kilometers, this is the largest unit, and I'm moving over to centimeters. That will take me 1, 2, 3, 4, 5 places to the right. This is going to be a large number because it's already at a million. And if I'm moving 5 places to the right, well, the decimal's right here. So 5 places over is going to give me 5 more zeros. 1, 2, 3, 4, 5. Add those zeros. So my number, I'm write this answer down, is 1. I believe this is 100 billion. Count. Yeah, 100 billion centimeters is my final answer. And the second one takes us to customary units because you see we're talking about pints and gallons, and pints and gallons are all in the customary. So I want to set up my dimensional analysis chart with pints per minute written as my first fraction ratio. 5 pints over 1 minute. And I want to go to gallons per hour. So let's start with changing our pints. From the gallon man up here, you can see that there are 8 pints in 1 gallon. So I want to get rid of pints. I need to put pints at the bottom. I'll put 8 pints here, and 8 pints is 1 gallon. So I'm going to put 1 gallon here. Doing this allows me to get rid of my pints. And now I'm at gallons, which is where I want to be. But now I need to also move from minutes to hours. And there are 60 minutes in 1 hour. So the 60 minutes will have to go at the top, minutes over minutes, okay? And the 1 hour will go underneath it. Doing this allows me to cancel out my minutes, and this is what I want left is hours, gallons per hours to be exact. So I just need to multiply across the top. 5 times 1 times 60, that gives me 300. And then 1 times 8 times 1 just gives me 8. Divide. Okay, so I get 37.5 So my answer is 37.5 gallons per hour. Next, number 3. We're going back to metrics because we're going from milliliters to liters. So I'm going to be moving my decimal again. This time I'm starting at milliliters and then moving to liters. Well, milliliters is the smallest unit right here, and liters is behind it. So I'm going to go 1, 2, 3 to the left. Go to the end of your number where your decimal is right here. And if I'm moving 3 to the left, this means my number becomes smaller. 1, 2, 3. And this gives me the number 1,000. 1,000 liters. Number 4 goes back to customary because from here we're going from gallons to gallons, which it's already done for us because if I'm going to gallons, I'm really staying at gallons. But I want to go from minutes to hours. So this conversion dimensional analysis chart is going to be super easy. We just want to write our first ratio, 5 gallons per 1 minute, and then change from our minutes to our hours because we want to stay at gallons. There are 60 minutes in 1 hour, so I'm going to write 60 minutes over 1 hour. Cancel out your your minutes. And then if I multiply across the top, I've got 5 times 60, which gives me 300. The bottom will just be 1, meaning we're just left at 300 gallons per hour. So for number 5, we're actually left to go from customary pounds to metric unit of kilograms. To do this, I'm going to have to cross over. So I need some type of portal unit from where I can go from one unit to the other, one measurement system. And when I come back up here, one of the things that I had you write down was that 1 pound equals 454 grams. So from here, I can take my pounds to grams and then move it to kilograms. All right, let's do that. Set up your first conversion part as 35 pounds. And if I want to go to kilograms, I need to get out of pounds, which means I'm going to put 1 pound here. It looks like 11. Let me fix that. 1 pound is 454 grams. I'm done with pounds, but I need to get rid of my grams. So I've got 2 options. Either I can write how many grams are in a kilogram and continue my chart, or I can stop right here and change my grams to kilograms. Because I know if I'm moving in metrics, if I want to go from grams to kilograms, I'm simply moving my decimal 3 places to the left. So I can simply take the decimal here and move it over 1, 2, 3 places to the left. This now gives me the number 0.454 kilograms. I no longer need this anymore. Okay, so then all I'm doing is multiplying 35 times this new number, 0.454 kilograms. Okay, and if you multiply this times this will give me my answer in kilograms, which I got to be 15.89. If we're rounding to the 10th, then that would just be 15.9. Number 6, I'm going from feet per second to miles per hour. And feet to miles stays within customary units, so we don't have to transfer over. We just need to know the number of feet in a mile. So set up your conversion, and that is 100 feet per 1 second. And I want to go to miles per hour. So for the first relation, I know that there are 5,280 feet in 1 mile. That's what I'm going to place here so that I can cancel it with the feet here. This gets rid of feet. And now we want to go from seconds to hours. So if my seconds are at the bottom, I need my seconds to be at the top. I need to write that there are 60 seconds in 1 minute. And this will get rid of my seconds. And now I want to write 60 minutes is in 1 hour to get rid of my minutes. This leaves me with miles per hours, which is what I want. So now all I have to do is just multiply across the top and multiply across the bottom. When I multiply across the top, I am multiplying 100 times 1 times 60 times 60. That gives me 36000. I think I'm missing a 0. Yeah, I am. Sorry. And on the bottom, I need to multiply across 1 times 5,280 times 1 times 1. And that's just going to give me 5,280. Once you divide this, your final answer, I've run out of space. Let me come over here. Should be 68.18. When rounded, will give us 68.2. And it's miles per hour. 68.2 miles per hour. Number 7. If a car is traveling 75 miles per hour, how many feet will it travel in 10 seconds? Okay. I want to set up my conversion table, placing 75 miles. Oh, my line is so crooked. 75 miles over 1 hour. And I need to go to 10 seconds. So let's just get to seconds first. And feet per seconds is what we're looking at. And then I'll deal with the 10 part. From here, again, I need to know the relationship between miles and feet. And the relationship is that 1 mile is 5,280 feet. This gets rid of miles. I want to go from hours to seconds. So that means I need to know the relationship between hours and seconds, or I can go from hours to minutes and then minutes to seconds. Well, 1 hour is 60 minutes. This gets rid of my hours. And 1 minute is 60 seconds. I don't know if you noticed this or not, but we don't want to be at just seconds. We want to be at 10 seconds specifically. So what I want to do when I'm done with this answer is just multiply by 10, or I can just from right here extend this and put my 10 seconds here. When I do that, it'll get rid of my seconds, and then multiplying out, my answer will be in feet, which is what we want anyway. Now I'm going to multiply through the top. 75 times 5,280 times 1 times 10 over 1 times 1 times 60 times 60. Okay. Dividing through gives me 1,100 feet. A leaky faucet drips at the rate of 1 pint per hour. How many gallons will it drip in a 24-hour day? This one's quite simple because we know that there are 8 pints in 1 gallon, 24 hours in a day. So we can just simply divide on this to get 3 gallons, or we could set up our conversion chart starting with our 1 pint per hour. That is so sloppy. Let me change that up a little bit. All right, 1 pint, I like that better, per 1 hour. And I want to go to gallons per day. Again, there are 8 pints in 1 gallon. This gets rid of pints. And I wanted gallons, but I need to change hours to days. So that means I'm going to put 24 hours 1 day. And this is where I get rid of hours. And like I said, we are left with gallons per day. Okay. And I just need to multiply across. Answer, 3 gallons. A car is traveling 100 miles per hour. How many meters does a car travel every second? Okay, so we look at this and see that we're going from miles to meters and then from hours to seconds. Let's start with one thing at a time. I want to change my miles to meters. In doing so, I need to be able to find the portal where I can go from miles to feet or meters and over to metric, because I'm going from miles, which are customary, over to metric. Set up my first portion, which is 100 miles over 1 hour. And I want to go down to meters. So let's get down to centimeters, because I know that 1 inch is 2.54 centimeters. So if I want to go from customary to metric, I need to cross over at that point. And I'll start again by taking miles down to inches. 1 mile, this is going to be a long one, so prepare yourself for this, is 5,280 feet. One foot is 12 inches. And now here's where I'm crossing over to metrics, because I know that 1 inch is 2.54 centimeters. Cross out your inches. And now I'm at centimeters, but I want to go to meters. So in metrics, all I have to do is move my decimal. I can simply take my decimal from 2.54 and move it over to get to meters, and then I'm there. So that's what I want to do. The number is 2.54 centimeters. If you look on your metric chart, converting from centimeters to meters require that I move the decimal back 2 places. So 2 places to the left means I'm going to move over and add a 0. So this number will now become, I'm going to write it here, 0.0254, and I have moved it to meters. I no longer need this number anymore. I've just changed it, so I'm not using that anymore. This almost finishes me out because I need to now move down to seconds. And to move to seconds, remember I've got hours over here. I need to convert that down. 1 hour is 60 minutes. And 1 minute is 60 seconds. Notice, let's see, how many meters does it travel every second? Well, good, I've got meters here and seconds here. I know that the leftover units where I want to be, so I just need to multiply across the top. Everything across the top is multiplied. Everything. Everything across the bottom is multiplied. When you are done, you should get 44.7 meters per second. The next one's quite simpler, much simpler. I want to go from inches to meters. And again, inches is customary, meters is metric. So come up here and look at your conversion to transfer over from inches to metric. And 1 inch is 2.54 centimeters. So I'm going to set up 1,000 inches. And proceed to change to meters by writing down that 1 inch is 2.54 centimeters. Once I get to centimeters, we know we can move straight over to meters, because centimeters to meters is a metric move. Centimeters is here, meters is behind it, 2 places to the left. So I'm going to move my decimal 2 places to the left, which puts it here, and I've got to add a 0 there. This means my number is now 0.0254 meters. I no longer need this number anymore. Now I simply multiply across the top and across the bottom. It's just an understood one. This gives me 25.4 meters. Jenna's heart rate is 60 beats per minute. If this is her average heart rate, how many times will her heart beat in 30 years? Okay, so we want to start this off with our first 60 beats per 1 minute in our chart. Take what's given, 60 beats, and that's in 1 minute. And we want to go to how many times her heart will beat in 30 years. So what do we know? Well, we know that 60 minutes is in 1 hour. Ooh, did not mean to do that. Okay, and this gets rid of my minutes. I'll need some more space in my table here because I want to go from hours to 30 years. So that means I need to get from hours to days. And there are 24 hours in 1 day. Let's proceed with this because we know that there are 365 days in 1 year. And we want to get down to 30 years. So I'm going to put 30 years here. And now all I have to do is cancel out hours with hours, days with days, and then years here will give me the number of beats in 30 years once I multiply across the top. So I've just got to multiply this times this times this times this times this. All of it's over an understood 1. Okay, so what I get for my answer when I multiply is 946,080,000. Add those commas helps to read it. And that's 946,080,000 times. From here, it says if Jenna's heartbeat 604,800 times, 604,800 times, how many full days would have elapsed? Okay, so now let's take her heartbeat, write this down. What's given to us, 604,800 beats, or times rather. How many full days will have elapsed? All right, so let's write what we know. That back up here, her heart rate is 60 beats per minute. So I'm going to write 60 beats at the bottom to cancel out beats per 1 minute. This gets rid of my beats. And from here, I want to go from minutes to days. So I need to know the relationship between minutes and hours, and then I can proceed. There are 60 minutes in 1 hour. And there are 24 hours in 1 day. Notice I am careful to write the units that I want to cancel out diagonal, so that minutes cancels with minutes, hours cancels with hours. From here, I will multiply across the top and across the bottom, and then I will divide. How many full days will have elapsed? Check your math. It should be 7 days.